Assalamu alaikum, my name is Malaika Khwab and in this video I will demonstrate UART communication using AVR microcontroller. We will cover two tasks. The first one is UART communication with LCD display, transmitter and receiver, and the second task is a simple digital transmission using a push button and LED. Moving towards the first task, the first line is a clock definition tells compiler MCU runs at 16 megahertz. Then there are LCD pin configuration like you mapped LCD pin using macros, and then there is lcd.h library helps for connections. There are also libraries like util delay, which is basically for uh, delay used, and then there is also std lib.h, which is for required function library, and also avr give access to register port ddr uart etc. And then moving towards the code, like the first line in main word like program start here, and then the port configuration like ddrd line set port d as output lcd data pins d0 to d3, and then this the second line ddrc set port c as output like lcd plus control pins, and then lcd 8 and I uh, here basically initializes LCD in 8-bit mode, and then UART configuration like UBRR register sets baud rate to 9600, and then enable transmitters also sets 8-bit data format, like then there is masking process like you can see which sets 8-bit data format. Then there is an infinite loop which basically runs for hours, and before it there is an array to store string for LCD, and then there is ITO count converts number to string, and then the LCD8 set cursor displays label on LCD, then displays number, wait until UART buffer is empty, and then send data through UART. The count plus plus basically is for increment value, and then there's delay for readability. Basically each loop sends incremented data through UART and displays it on LCD. That's it for transmitter part. Moving towards the receiver part, the start is same like there are libraries I have explained before. Moving towards the main part, there is a UART setup which enables receiver, and then there is uh, a setup for 8-bit data, like they have masking process, and then UBRR registers the same bound rate, and there are then variables which store data, and car count string for LCD, and there is loop which wait until data is received, then it receive data and read it and convert to string. Basically receiver waits for data, reads it and display it on LCD. That's it. Moving towards its Proteus part, let me show you. In Proteus, I designed a microcontroller circuit. The transmitter sends incremented data through UART, and the receiver reads this data and displays it on LCD. Both devices are connected using TX and RX pins with a common ground. That's it. Then comes our second task, like which is basically button to LED. The first after libraries, the first line DDRB like data direction register is for port B, is setting port B as input button, and then there is if condition. Basically, it reads button state and then send password sends uh, like if it is 1 it is pressed, and if it is 0 it is not, the button is not pressed. And then there is while condition wait, which is wait until UART is ready. Like we must check on UDR is 0 before sending data. The transmitter reads button input and sends digital data through UART. That's the transmitter part. Moving towards our receiver part. In this code, the port C as set as output like LED, and then the while condition which waits for data, and then comes the if condition like if received 1 LED is on, and if we receive 0 LED is off. The receiver converts received signal serial data into digital output to control on LED. Moving towards its Proteus circuit, in the circuit, a push button is connected to the transmitter microcontroller. When the button is pressed, a logic 1 is sent through UART. The receiver reads this data and turns on the LED. When the button is released, 0 is sent and the LED turns off. Basically, in these tasks, UART communication is implemented to transfer data between two microcontrollers. In task 1, numerical data is transmitted and displayed on LCD, while in task 2, digital input from a button is transmitted to control an LED. That's it for today. Thank you so much.